We will see in this video how to create a singular element in the Meke Flux Pro 3D software using the Singular Element Editor. To access the Singular Element Editor, we go to the library in the left pane. Here, we select the icon Singular Elements Editor. This opens the interface for creating singular elements. We click on New to launch the creation of a new element. This sends us to the tab Define the Element, where we will enter the parameters of this new element. For this example, we have chosen to create a singular element, chosen from an abacus in the specialized literature. Here, we have selected an extractor hood with a singular pressure drop coefficient of 0.5. It is important to determine the section to which the calculations apply. The section determines the base speed for calculating pressure drop. This reference section is shown here by an arrow and a V. This is the fluid outlet section. We also note that this element has an inlet and an outlet, which are not of the same diameter. So we are going to check in the definitions of the new element the option indicating that the input diameter is different from the output diameter, and we will determine on which section the calculation is based. Here, the pressure drop coefficient applies to the outlet section. We see the arrow drawn. We just have to enter our coefficient, which is 0.5. The pressure loss coefficient is fully determined. We move on to the diameter parameters. Our element has an entrance diameter, which is not connected, it is in the open air. In this case we enter a 0 input diameter, 0. And this hood has an outlet diameter of 200 mm. Here, we have to name this singular element. We name it hood, and we mention its connection diameter to facilitate its selection in the library. Diameter 200 mm, and we will finish by choosing an image for this hood. We use the Edit Image function, and we select the image of the element, and here it is applied for this element. For aesthetic reasons and readability, it is preferable to correctly align the image with the direction of the flow. We have a small diagram which indicates the position of the entry, the position of the exit. Here, the direction of the fluid is not in correspondence with the image. So we have a small tool which makes it possible to pivot or to reverse until the position is well determined. Here, the entrance is done well by this side, and the exit on this side. It only remains to save this element. And that's it, it's over for this element, it has been created. We can close the editor, and we go to our library of singular elements. Find the hood that we have just created. So we're going to do a test right away. It's a hood, so it's the entrance to a network. We will drag it into the empty interface. This creates a new network starting with this element. So, then I can click on the hood to select it, and use the Continue After function. This will create and connect a duct of the diameter of the hood outlet, 200 mm. And we're going to orient the vertical conduit. So I select the base of the element to center the grid on it. And then I select a grid point vertically to validate. So we have a network that starts with a fume hood. We can perform a pressure drop test. We're going to do a test at 200 cubic meters per hour. with air at 20 degrees. We will leave the altitude at 0. We go back to our diagram, and we create a generator, which will produce a flow of 200 cubic meters per hour. Our debit generator has been created. We will take the opportunity to show the tricks in terms of the ergonomics of the software. When the flow test was launched, the generator was automatically inserted at the first position on the network, where the diameter is different from 0. In this case, this bothers us in the representation, because our generator hides our hood. This is not very ergonomic in terms of presentation, and may not represent reality. So we can select the generator, right-click, cut, and use the function, insert downstream of the straight pipe. Here, this will be clearer, and closer to reality. We can run a test again. So now, it's a little more visible. We can edit our pressure scales, and see what is happening in this conduit. So here, the atmospheric pressure is in pink at 0. And we see a suction depression up to the generator, which shows a maximum depression in suction here, and discharges at atmospheric pressure. Depression is 3 pascals. It is the depression that must be generated in this system to combat the pressure drops and ensure the speed of the fluid. That's it for this tutorial on creating singular elements with a constant pressure drop coefficient. We will see in another tutorial how to create singular elements with variable pressure drop coefficients according to adjustable parameters in the Meke Flux Pro 3D software.